Hey DJ Microbeats, what's going on? Starting a little bit late because I just took my dog to the vet for vaccines. Hey Sint. Nice house climbing. Plus, what are you cooking? Yeah, he's perfectly fine. It's just like a regular checkup and vaccinations. Yeah, he's doing great. He's napping right now. Pumping station, that's cool. Okay, so I'm gonna get started. So last week I left depth of field sort of half working, and then I worked on it a bunch later because I really wanted to see it looking nice. I think I'm still doing the thin lens model incorrectly, but I just want to show what I have right now. Let me make sure I have, okay, yeah. Oh, is it the like carburetor noodles? Radiatory or whatever, named after a radiator. Also I changed it to Verlet integration, so it is actually more boring looking now. Although if I turn up the I left it in kind of a broken state, I think. Oh wait, let me turn down my acceleration. Ilicio Dali. That's cool, yeah. I need to branch out on my pasta types. Okay, yeah. So it is showing kind of some like cooler clustering than before, with the Verlet on. Anyway, so yeah, this is kind of where I got it to. I've posted some videos, but I'm pretty happy with it. I think that depth of field probably looks more interesting on things other than like pure point particles. But anyway. Okay, so I'm gonna commit this, and then I'm gonna make some pretty drastic changes today, because I'm no longer gonna be working on particles. I'm gonna be doing height field rendering with polygons. My end goal is to do something with. I want to do basically a renderer in the Reyes style, which is the way Pixar's original renderer worked from the 90s, which is based on, oh, what's the physics now? It's still inverse squared, just with Verlet instead of forward Euler, which is what I was doing. Funnily enough, the Verlet just makes motion blur even easier because now you just have the previous and the current position values. Hey Charlie, what's good? So yeah, it's the same physics, it's just a better integrator. Anyway. So yeah, what I'm going to be working on is, I'm going to, for today, just start rendering height fields. I want to experiment with mesh representations that are less pointery and indirection based than on the standard GPU triangle mesh formats. So like a height field, for instance, is a good example of that because it's basically just a texture of Y values. So it's really like stored coherently. You can access a polygon's neighbors trivially because they're located next to each other in the texture. So as an overview of the rendering architecture I'm going to try, there's a whole lot of ways you could do height field rendering. Like the classic way, I think Comanche, the game, was height fields. And I'm pretty sure they had like, there's like a classic sequential ray marching algorithm where you march one ray for each column of pixels, and then you just kind of march upward on the screen as you go further back into the terrain. And that's a pretty classic way to render height fields. And then in in a GPU context, you kind of want more parallelism than that, but people still do height field ray marching, just kind of, hey Lewis, just kind of like per pixel rather than per pixel column. What I want to do rather than marching or tracing in that way is I want to generate quads or triangles for grid cells in the height field. Eventually I want to have like a very tuned tessellation so that there's approximately 1 polygon per pixel, but for now, my first attempt, I'm just going to do a regular grid of polygons. And unlike the standard way of rendering on the GPU where you shade pixels, you render polygons and then shade pixels, I'm going to be shading polygons and then rendering the polygons to pixels. So first I'm going to just take all the stuff that I have and commit it, and then make a new branch and start working on the height field stuff. Okay, so I got a new branch. The current state of things is particle renderer. So I still am going to be rendering into a texture with a compute shader and then blitting the texture to screen with 2 triangles. But this time I'm going to, it's going to be a color texture rather than just a monochrome texture, and I won't be doing additive because I'll need a Z buffer. So I'll have to change most of my setup. So that's why I'm doing this on a new branch so that I don't mess up the original stuff. And I might eventually try to maybe salvage some of the particle rendering and combine it. But I'm thinking maybe I might just want to use a different method for particle rendering that actually uses the Z buffer if I integrate it with this. Yeah, Get GUI, I talked about this last stream, it just really gives me control character spam in the terminal. Anyway, so here is my fragment shader that's currently drawing from oh yeah, I also, another thing I added since last time, I added the relay integration. I got depth of field actually working how I wanted it to, and then I also added dithering, which is not going to come across on the stream, and it's also not going to come across on most videos or images I exported if they're compressed, but I was getting some banding. I also want to do a more sophisticated dithering. There was a really good presentation from the Inside graphics engineers. I'll see if I can find it, but anyway, they talk about like triangular dither, where you only dither if you are close to a quantized value, like close to an integer value for the RGB, and then if you're halfway between, you're already basically randomly being rounded off up or down. So you only add random noise that's like shaped like a triangle for high near the integer values and then low near the half integer values. And then there's more sophisticated spatial patterns like doing blue noise instead of just white noise. So that's something I can get into later. But for now I just was doing like a per channel white noise addition. Yeah, it's not even triangular. It's just uniform right now. Yeah. So it's not that sophisticated right now, but it does do the job. I was having some banding and it did break it up nicely. So okay. So let me think about what I need. First thing, I'm gonna comment out all the compute shader stuff for now. Going to be kind of a mess in here. I'm just gonna create a texture and then draw it to the screen with 2 triangles, but it's going to be a RGBA texture instead of a, or maybe it should be HDR. Maybe I should do like a higher, add 2 uniforms, right? Yeah, that makes sense. Okay, I will do that next time. Okay, so I'm clearing my screen. Then I bind the texture, draw it with my fragment shader. So comment out all of this compute shader dispatch stuff. This is creating my triangles for rendering. This is the shader for rendering triangles. This is the texture. This is all my compute shader particle stuff. So I'm gonna comment this out. So now it's just clearing and drawing a blank pair of triangles. So let me change the format of that texture to be gen texture, bind texture, store I. Where do I actually set the format? Oh yeah, this is where I do it. Okay, so I'm clearing my texture every frame, which makes sense. So this is where I actually set the format. Yeah, that makes sense. Okay. 1600 by 900. Instead of R32 UI, I can do, because I'm not doing additive blending, I don't need it to be integers. I can actually do like a floating point buffer. Maybe like a half float. Okay, let me look back at the texture types. So text image 2D. So the formats we have are so yeah, the RGBA 32F would be the big boy. RGBA 16F is the more reasonable boy that I think I'm gonna do. Do I need alpha in here? I don't actually think I need alpha, but I do need a Z value. So I may as well just hack in the Z value as the 4th channel. If I decided to use atomics for doing the Z buffer, then I could just have the R channel be the first channel, be Z, and then make sure that Z values are ordered the way I want them to be, and use atomic mins, because I've seen this done before. There's a cool thing about IEEE float formats where if you compare them as 2's complement integers, you get the same ordering. So like 2 floats will always compare less or greater by integer comparisons if the corresponding floats are less or greater. So I think what I'm going to do is RGBA 16F with the Z value in the R, and then the GBA are actually the RGB, and then that will let me, because that makes the R be the high bits, and then I can use atomic min. Okay, so RGBA 16F, and I'm just gonna fill it with 0 bits, which means that it will be floating point 0. I don't have a half float library, or I haven't written a half float conversion thing, so if I want to actually put data in here, it'd be harder, but it's fine because I don't for now. I just want to clear it. So RGBA 16F, and then I've got to have this image. U32 is okay as my format. because it's just got to be the right bytes. And then these need to change from red integer RGBA 16F. I think okay, so this, I forget how this works every time I call it. Internal format, and then type. So why do none of these types match my? I guess this is type is for the data that I'm pulling in. So yeah, I think it is. That actually makes it easy. I think this lets you use integer texture on the CPU side and then upload it to floating point texture. So yeah, it's going to be unsigned int, I think. So yeah, that's actually fine to leave as is, but I need GL RGBA. I'm curious if I could use BGRA. No, because what I would want is the A to be first for that atomic thing. Integer comparisons. I think it depends on the GPU. The reason I'm using that is because you literally don't have floating point atomic operations. Like, if you want to do atomics, they have to be unsigned ints regardless. So yeah, I would just be using float atomics even if they were slower if I had them. I think it depends. There's some interesting stuff like I think the new NVIDIAs have like, they can do integer and float operations in parallel with each other. So, but I don't know if the integer ones are necessarily faster. Yeah. The spectral painting implementation uses 3 RGBA textures to get 12 spectral. That's actually cool, yeah. That one just uses WebGL, right? Like it's just like classic fragment shader stuff and regular RGBA textures. JIT type confusions from floats to array pointers, so they have constants. Like, nice, yeah. Reminds me they're probably getting bigger brain than this. The ones I remember are just like Lua using NaN tagging. Yeah, it is pretty horrifying. Okay. So I'm just gonna say RGBA for now and see if something breaks. And if it does break, I know where to look. So now I think I need to change the fragment shader from the texture format. Something did break. I got a seg fault, so I'm assuming that this size doesn't match what it wants. I think unsigned int might be saying that each channel is an unsigned int, so it wants 4 times as many as these. So maybe I need unsigned byte. Let's just see if that works. Yeah, so the problem was that unsigned int was like per channel. Unsigned byte is the standard, like 1 byte per RGB channel. Oh, spectral painting. I was thinking of the spectral 2D path tracer thing. That's what I was confusing with. Literally typing out a URL from my phone. I want to see this. Okay, yeah. Here we go. This is cool. Yeah, I remember you doing stuff with this, but I was thinking of something else. So now, if it's full of zeros, let's treat RGB. Let's treat the R as a Z value. So ignore it, and then draw the GBA as RGB. I'm just gonna comment out my random and my dithering stuff for now. I just comment all this out. Let's call equals So just take the GBA channels and output them as RGB, and then we have a 1 alpha. So this should be black. Oh, and it's just like RGB colors. Yeah. Okay, anyway, it works. So we're drawing a black texture. So now we can make a compute shader to blast things into it. So my plan here is I'm going to have 2 stages. One that takes... Honestly, I might only need 1 stage. If I have a height field that I create on CPU, and then I run a compute shader over it, and it, for each quad in the height field of like a 2x2 square values, I just rasterize that as a quadrilateral into the frame buffer. Then I think I only need 1 pass. If I were doing something more algorithmically interesting, like binning those triangles and then I would need a multiple pass. But I think for now I'm just going to generate the height field on CPU. So I just need 1 compute shader pass. So let me make a compute shader called rasterize. Doesn't have an int-type hybrid int that's promoted to float. NAND boxing, that's what it's called, yeah. Boy, I love not having integer types. Something I discovered the other day was the ID function in Python that gets like the pointer to an object. It gives you the same thing. Like integers are interned basically from -5 to 256. So if you do ID of 2 plus 3, it's equal to ID of 5. But if you do ID of 256 plus 1 and ID of 257, then those are the same too. Okay. Maybe I am wrong about this. Okay, maybe I am wrong. The doc said that it was -5 to 256, and I reproduced this earlier. Yeah, it is. I think it's probably because of like status code returns. Although I don't think Python uses that very much in the standard library. But it might have been a convention that was decided in like 1992. Anyway, okay. So where do I create my compute shader? Let me just create my rasterize. And then rather than using an SSBO this time, I'm just going to be using another texture for my height field. So let me copy where I was finding my images. Oh, another thing that I implemented since last time was mouse rotation and zooming with the scroll wheel, so I'm going to keep that because I want to be able to do that with my height field. Okay, I'm just going to get rid of all of this SSBO stuff. So I need to make 2 textures. My second texture is called height field. I think I'm just going to do nearest neighbor, and I'm probably just going to actually do texel fetches on it. Because I don't think I want linear blending, because linear interpolation, sorry, because I'm using it as geometry. Like I'm using the values in it as like vertex coordinates. So I still want nearest. I guess I still have my stream title as GPU particle systems and flocky behavior, so I'm going to change that to heightfields. Anyway. So I'll create my other texture, and then I don't need to clear it every frame, so I'm just going to create it once at the beginning. And I'm going to decide that it is 1024 by 1024. It's going to be a single channel float texture. R32F. The data type is going to be, can you upload float data with type? You just give it unsigned byte, even though it's actually GLFloat. I guess you just give it GLFloat, and the docs were not helping me. Okay, yeah. R32F. Oh, this is what should be R32F. This is GLRed, and then GLFloat. Then I upload my big texture of zeros. So now I have my height field, and eventually I'm going to do like actually interesting height values, but for now it's just going to be zeros. So now I'm going to take my draw shader code and adapt it for the rasterized shader. So just like before, I'm going to have write-only image, but it's going to be, wait, I didn't think this through. I can't write atomically to a full, to like a, wait, yeah, I can, yeah. 4 half floats gives me a 64-bit. Are they atomic 64-bit, or are they 32-bit? Image load store, atomic operations. So they work on image locations. They can only be used on images with the R32I or R32UI. You can use format conversions. This is tougher than I thought to get working. Like, potentially, I could just have a unsigned int that encodes like an ID into the texture, like where the high bits are the Z and then the low bits are the coordinates in the texture. And then I actually compute the colors elsewhere. Or I could just do bitwise in the GLSL to pack. But does GSL even give you like a reinterpret cast from floats to ints? I don't even think it does. Okay, I may as well just do give up on floats for now for my color buffer, and I'm just going to do can only do 32-bit atomics. I lost the chat on my phone, so let me go see if anybody said anything. If anyone has ideas in chat for this kind of stuff, let me know. So I only get 32-bit atomics. So I need to figure out how to... Do I only get... I'd have to like pack my Z value and my ID into... Maybe I can use an SSBO for it? Atomic operations, int or uint, which would be 32-bit also. So I might have to have like an extra step here. Maybe I have to like do binning, or I can just do a tracing, but I really wanted to do a rasterizer. Like I don't think 16 bits is enough for depth. Maybe a 16-bit float is enough for depth, though. But again, how do I do that bitwise in GLSL? The more complicated thing I could do is like binning triangles into linked list per pixel. And then finding the closest Z in another pass. Image load store. So if I just wanted to write Z's into a Z buffer, I could do that pretty easily. So maybe I should start with that. Kind of frustrating. For some reason in my mind, I was thinking I could just do 64-bit atomics, which would solve everything. So for now, I think I'm just going to do Z values and run into a Z buffer, and I'll figure out what to do after that. So I have my RGBA. It actually has to be an unsigned int, so I'm going to go change it back to an unsigned int. Not in the format, but in the image format visible to the shader. So where I bind image texture, it should be Okay, let me go to the docs for bind image texture. Nope, I meant the first one. So yeah, what I want is just R32 UI. And that lets me use atomics on it. Rasterize should also have an R32 UI image. I'm going to have a transform and a Z like before as uniforms. And then I'm going to, I don't need any SSBO, but I need my main function. Chat wasn't working on my phone for some reason. Why does it need to be an atomic store if you don't have layered terrain? Well, the issue is not layering. The issue is layering in screen space. So like, if I have terrain like this, and then like one hill is in front of the other, that's multiple polygons of the terrain writing to the same pixel. So float bits to int, I do have. Okay, thank you, Lewis. That is a big help. Maybe I have to do something stupid like have the Z value in 2 different places in front of like the RNG channel and then the B channel or something. Or, man, I was really just expecting that I had 64-bit atomics. Okay. So at least I have float bits to int if I need it. So I'm binding my image texture. I'm giving it as a uniform. And then I'm gonna just uncomment my transform in my Z uniforms. No longer num particles. I'm gonna do, for now I'm just gonna do 1 thread per pixel. So, I mean not per pixel, per polygon. So, let me replace my hard-coded height field size with this. And then down here when I dispatch my compute, I'm gonna do so now I have 1 thread per polygon in the height field. Oops. Okay, I got chat working on my phone again. Okay. Oh yeah. Rasterize and rasterize. Renamed my shader. Okay, so it's still doing nothing, but it's running at least. So now I can test if my rasterized shader writing things into the buffer does anything. So I'm just gonna have every thread right into the upper left corner like before. So So it needs an image store. Image coordinate data. And then I'm just going to fill it with ones. So that would be, does GLSL have hex literals? It's 32 bits, so I have a to uint image store. Image core data. Oh, it's a vector, right? So in this case, it's got to be a uvec4. Okay. Don't see anything in the corner. Maybe I need a memory barrier. This is the same thing I was stuck on the first week. Okay, so this time I have render doc, so it should be easier to figure out what's going on. So we're dispatching compute, resource inspector, no, pipeline state, compute shader has a texture. Yeah, it doesn't look like I messed up my pipeline state this time. So let me check if I'm doing this part properly. Okay, let me just look over the code again. So I'm using my rasterize program. I'm clearing the image, the frame buffer image. It's got the format RGBA 16F. Maybe I should make the, yeah, the format's not the right size. RGBA 32. Yeah, there we go. Okay. It was just because the size is mismatched between the formats. So now I'm writing into my buffer. I'm going to change it so that this just draws Z values again. So maybe I should just go back to drawing transcendence from so I'm dividing my coverage by 16-bit max. then okay. But coverage is 0, so this should be blank. My blend mode is, oh, I'm pre-multiplied alpha, yeah, so it should actually be, actually I can just do this, I think. Just fill up a vec4 with coverage values. Yep, okay. So here we go. It's 0 everywhere in strong left pixel. So rasterize now needs to take the current, well, I need to feed in the height field texture first, so I'm binding image texture for the output, the frame buffer. I need to also bind image texture for the height field and create a uniform for that. Format of that is going to be 32-bit floating point, like I initialized it up here. Yeah, 32-bit floating point. Okay, so I'm gonna change this to R32F and then make it match it in here. R32F. So if that works, then we can start reading from the height field. Oh, it's not a U image 2D, it's just an image 2D. So now we're good to go. The height field is just going to have all zeros in it, but what I'm going to do is, so that it'll be a flat plane. So I'm going to, I need to have a transform that will show the flat plane. Okay, let me just draw it on screen to see that it's working. So I'm going to take the height value and just ignore it and use the x and y values instead. So it's going to be image atomic min for the depth, which means I should initialize depth to like the max value, which means I should fill my texture with 32-bit max value rather than 0. Image atomic min, image coordinates data, and it's got to be just the integer. That makes sense. Okay, so my x and y are going to be derived based on my thread ID. So maybe I'm going to just use dispatch compute. So I'm actually going to use height field size as both the x and the y sizes. And then I'm going to use my invocation ID, x and y, as my x and y coordinates. So this is a position vector let me see what happens if I use it as the coordinates to write into the texture. Okay, so it is working to, okay, so basically for the upper left rectangle, so this is like a max z value, and then this is where I've written into it as, oh, you know what, I should probably make my fragment shader not draw. Oh, yeah, everything makes sense. I have a 1600 by 900 Z buffer, and then I have my 1024 by 1024 height field that is currently just being atomic minned. So now what I'm going to do is I can take my invocation ID to XY, and that's my let me see, and then the Z value is going to be the value of the height field at pass this as a uniform eventually, but I'm going to just use it as a constant right now. So the height field value is image load. I gotta do the X and Y values are oh yeah, I don't actually need height field size because I just use X and Y directly as my image coordinates. And then I'm just going to put Z in for now. Narrowing a vec4 to float. Grab the R value. Hey Tech. Or Remy. So atomic min takes a texture, ivec2, oh, and it's gotta be as an int. Yeah, that's the problem. How's it going? Okay, so that's working. I'm just casting the float to an int. So now what I should do is here's my position. Let's see if that works. And then I'm going to transform this and see what happens. Oh, it needs to be a vec4. Yeah. So I just needed to give it a 1.0 because it's a homogeneous matrix, or for homogeneous coordinates. So yeah, position is, and then I can just make this a vec form. Yeah. So now it's filling up the screen with, no, it's doing nothing yet. It's not working anymore. So let me take out the transform. Let's see what the Z is causing. So yeah, it's not working anymore. Oh, Z value, yeah, okay. Position.z is what it's supposed to be. Of representation theory, interesting. Could you elaborate on that? Oh, I guess because, yeah, you have like a group of projective transformations. Or even just translations, yeah. You have a group of Euclidean or affine transformations, and then they aren't linear in n-dimensional space, but you find a linear representation of them in n+1 space. That does make sense, yeah. Okay, so let me put the transform back in. So, oh yeah, and now I can actually rotate this with my mouse. Nothing is happening. I should also do a z divide. So did I comment out my rotation stuff? I don't think I did. Yeah, that's still happening. And I am feeding it the rotation matrix. So I'm taking my x and y derived from the thread ID, and I'm taking my z, which is the value of the height field, which is all 0 for now. Yeah, exactly, yeah. Yeah. And then I'm multiplying transform by it. Oh, you know what? I'm just dumb. I'm not feeding it the transformed xy. So this is kind of drawing it as a point cloud. It's not... Okay, there we go. Something's happening. That's cool. I think, yeah, I need to be... For the perspective divide to work, I need to have the origin at the center of the screen. But something's happening, which is good. Let's comment out the z divide and see what happens. Okay, yeah, so this is like an orthogonal projection. Yeah, there we go, see? So we have an orthogonally projected plane, and as you split it up far enough, I don't know if I can do that. It's not going to be airtight, it's just drawing a single point. Yeah, here we go. So like, now the round-offs are making it have gaps between the points because I'm not like rasterizing, I'm just drawing a single point per polygon. Yeah. Anyway, so you can see it now. I'm gonna make my x and y centered at center of the screen, which is just quick hard code it as Oh, and then when I actually write to the screen, I need to offset them again. There we go. So now the vanishing point is in the center like it's supposed to be. My z values are too big though. Yeah, when I need to change my z values to be like 1. Although then when I write it into the z buffer, I need to multiply it back by something. So like kind of hard to tell what's going on like this. I think maybe I'm also, part of it's behind the camera and I'm not clipping. So maybe I can just say only draw if it's greater than 0. And I think that removes like the double thing I was having before. It's very confusing. I think also the problem is just that like it's too sparse to really make out the plane shape from it. Wait, and I shouldn't be drawing. Yeah, it should. My alpha should actually be always 1, I think. And I should just be drawing coverage value as a grayscale value. Yeah. Euclid orchard. When you get lost in Blender, yeah. I am doing camera Z translation right now, which is how my zooming works. I don't have translation in yet. I'm gonna do it after I get the rasterization actually working. Yeah, it's hard to tell what I'm even doing wrong here, so I may as well just do the actual rasterization. So what I'm gonna do for now is so each cell of the height field is a quadrilateral with 4 coordinates. So I'm going to load all 4 of those instead of just 1. So I think I actually need to have 1 fewer column and row of threads, or 1 more for the texture. Yeah, it needs to be like 1024 plus 1 texture for the edges. Okay, so now I'm gonna have I load my 4 height values with image load, so Manifold Garden, yeah, that is a cool looking game. Okay, so I'm gonna have my neighbor vertices. Maybe I should have this is my like XY values. So I'm grabbing my 4 positions, my 4 Z's. Oh, it's on the switch. That's cool. Yeah, he did a GDC talk on how he handled the like topology stuff, the like repeating world, both level design wise and like rendering wise. I don't remember any of the details of how he accomplished the rendering stuff. So now I'm grabbing my 4 positions in a little square, and then I need to transform all of them and z divide all of them. So now what I need to do is take the set of pixel centers bounded by this quadrilateral and do a atomic min into each of those. So maybe to start with, I'm going to use a conservative bounding box around those 4 points in the screen. And then for each pixel in the bounding box, use the line equations of the quadrilateral to test whether the pixel is inside it. And then if it is, I'm going to write the z value. So I need my x min and max and my y min and max. So maybe I should have put these in a little array from the start so I could write it all as for loops, but yeah, exactly. So that's how GPUs render triangles already is it's called Pineda rasterization. So they have 3 half planes that when intersected give the triangle. So they like take some conservative like tile or set of tiles overlapping coarsely overlapping the triangle, and then they do basically a bunch of dot products to test the actual inside-out tests. I think you can actually reduce it to finite differences if you're doing them in a coherent rectangle like that. So like you can just literally have, in hardware, you test in parallel every pixel center in the rectangle using like an add from the upper left of it. And in this case, I can maybe just do finite differences in the for loop. But for now, I'm going to do it the less fast way that I'm more sure will work. So I've done my z divide. Maybe I should have I'm gonna just like keep the coordinates in pixel space just for easiness and do I center them and then divide by z and then uncenter them again. And that will let me just use them as screen coordinates. So just going to check that these are still, that it's still working like before if I'm just drawing the upper left. So this looks slightly different than before, but again, I can't really tell what I'm doing wrong. And it's like drawing a plane in some sense, I can tell. Probably just got like a really drastic perspective projection. Anyway, on to rasterization. So now that I have my x and y values, I can compute the min and max ones. So the min x is going to be so I have my min x and y and max x and y. I think actually these work component-wise, so I could just combine these into one. Yeah, okay. So that gives me my rectangle, and I'm going to be taking pixel centers as the like ray position. So the pixel center, that means my minimum coordinates, they should be rounded up if they're, so I think I can literally just use round for the min. Obviously, if I were being actually more careful about this, I would. But I'm just going to try to get it working. So I'm rounding the minimum coordinates, which if they're equal or less than the center of the pixel, that will include the pixel. Otherwise, it will round it up. and for the max pixels, it will do the same thing. So I'm just going to call round for now, and then we'll, because it's going to take some care if I want to actually have watertight rasterization, meaning I don't have any like gap pixels in between my polygons. I'm going to actually have to like, what GPUs do in hardware is I know they, at this stage, they go to fixed point, and they have like a 256 sub-pixel coordinates or something like that. So I should probably do that and like maybe use a byte per sub-pixel coordinate. And they have a defined behavior for what happens when an edge of a triangle is exactly on a pixel center. And I'm being sloppy about it, but I'll just get it working and then we'll see. So for So now I'm looping over my bounding box, and then I need to take my, just for now, I'm just going to see if this is working for computing bounding boxes by putting in the z values. So like this should, if it works properly, draw kind of a, like the conservative set of bounding boxes of each quadrilateral making up the plane. Like 4 to 2, line 46. No, it's line 34. Oh yeah, it's because these are, okay, so I'm just gonna grab the x and y's here. I guess like often happens when I try to do this type of thing, I make a really long or infinite for loop in a shader and it hangs the program. I can't see why this would do that though. Yeah, compute.exe has stopped working. I think now it's working because it just optimized out the for loop. Let me just limit the size of the bounding box to like 4x4. And then hopefully that prevents infinite loops and crap. Okay, yeah, so now it's supposedly drawing 4x4 things. It's not actually. It's still doing individual points. Maybe, maybe I can just set it to be min plus 4x4 to see if it's actually working to draw a little square. Well, it's slow. Very slow for some reason. And it is not drawing squares. So that doesn't make sense. Oh. Because I'm not actually adding. the values. Okay, now it should be drawing rectangles. Even more confusing than before. Slowing down the stream, nice. I don't understand because this is like each thread is just doing a like a 16 long for loop. 16 atomic mins per thread should not be having that effect, I think. Oh, you know what? Typo right here. Probably the cause of everything. Okay, yeah. I was mixing up X and Y coordinates. So it was doing like screen long stripes. So it was doing many more than 16 atomics. It was doing like 900 times 16 atomics in many cases. So now I can go back to what I had before. Wait, yeah, I don't need to do that. I just see if my original code works now. As long as I have Y's here. Hung again. So let's make it back to what I had before. So clamp the size to a 4x4 box. And not all of them are 4x4 boxes, I guess. But okay, let's maybe extend this to like 32. There we go. Somehow it's like down in the corner like that. It's really infuriating not being able to tell what's going on. Okay, well I may as well do the actual line equation tests. So so the way to do that is I have 4 points. Each pair of points going clockwise is if I cross against that vector, then I'll be to the right of it if it's positive, if I cross with it. So So I'll make my 4 line equations. These are, I'm going to change the order of these so that they're counterclockwise. Or I think it's clockwise, but in any case. These are my 4 edge vectors for the quadrilateral. And then I need to cross with them. So this is my line equation thing. So all 4 of these have to be positive for so let me just put this in a big ol' and then I'll include the z is greater than 0 thing. And then in that case, I do the min. So I'm doing my 4 line tests. Let me just change these to less than 0. See if it does anything. Okay, now I'm getting nothing. There's some dumb mistake in here, I'm sure. So here's my 4 positions going, they're going clockwise around the quadrilateral. Although after you transform them, they're still going to be going one direction around it. So, but the projection can actually flip the winding on screen. So that might be an issue, but it should at least be showing something at some point. Let me try getting rid of this min at the risk of hanging and slowing down the stream again. Yep, it did. Okay. I need to figure that out. I'm gonna shrink everything on the screen so that it takes up a smaller area so that I'm limiting the amount of pixels that a quad subtends. You know what? I need to be transforming relative to the center of the screen also. So like, yeah, that's one thing that's not making sense. it's like... Okay, so I'm just going to take out the z divide for now. Okay, so that looks like a plane again. So now I'm going to shrink everything a bunch. So this is my coordinates at the relative to the center of the screen, multiplied by my rotation matrix, shrunk down, position relative to the top left of the screen. Also, I think I might be displaying the colors wrong so that it's not getting any grayscale. There is no cat. I don't have a cat. It could be my phone vibrating, or it could be my GPU fan going off. One of the two. Okay, let me just fill the texture with, like, half values and see if it properly draws grayscale. Why is it not drawing grayscale? Okay, I'm gonna literally comment out my compute jitter call. So I'm filling the buffer with 65536 over 2. Let me just fucking fill it with 127. Yeah, I'm very confused why what this is just like full white or full black. Okay, how big is this? Okay, so it's close to 32 at max still. So maybe I'll just take that and divide by it. Okay, I think the problem is just texture formats with why this wasn't working. Yeah, okay. Wasted a little bit of time on just figuring out the texture format. Anyway, this should display properly now. So let me go back to actually running the shader. And then I'm going to multiply by U32 max in here. Multiply my z value by that. Why is it basically either? Okay, I see some gray values there. So that's good. But this is all black. Okay, there's a little bit of gray on the fringe. This might be overflowing. Alright, I have no idea what's going on now. I do have grayscale values sometimes, I think. Not right now. Last time I did. It's hard for me to figure out what exactly this is rotating around. see if it's somewhere gray scale now. Still black. That is very confusing. Okay, gray on the side, right there. There we go. So like my transformation matrix right now is starting out doing nothing. And so it should be just drawing a rectangle to the screen like before. Now it's drawing a rectangle to the screen. But I'm getting garbage up there. That's cool. So it should be doing the same thing as before. I don't know why the rotation matrix is screwing it up. Oh, I'm thinking maybe I should have my... I should be rotating it around a point in front of me. So like... Alright, see you soon. Thanks for tuning in. It should really be doing nothing though. Like, I still can't get over that. The transformation matrix is identity. And if I comment it out, it changes. And I think probably this is gonna have to be a kind of disappointing stream where I don't get very far, because I think I have to go walk my dog pretty soon. But I guess doing rasterization in a compute shader is more work than a 2-hour stream. Maybe surprising. Okay, why is this doing nothing now? Definitely just doing something very dumb. Am I missing a barrier or something? No. Yeah, okay. Every frame I'm clearing the image to U32 max, U32, R32 UI, red integer, unsigned int. I bind the texture as R32 UI, write only. Maybe it has to be, does it have to be read write? It didn't when I used atomics before, so yeah, I don't think that changes anything. You know what? The height field is supposed to be read only. That didn't fix it though. Alright, I have to go take my dog on a walk, so I think that's the end of this stream for this week. I might work on this during the week sometime. Spend some more time staring at what probably dumb OpenGL mistake I made here. Honestly, I should probably write more of an abstraction layer over it so that I stop making these kind of mistakes on stream and I can actually like do more interesting stuff. Okay. Dog is going on the stream.
Hey, buddy. Come here.
Here we go.
Say hey, bud.
I think he's grumpy from the vet. You're doing okay, huh, bud? Chat loves the dog. Anyway, Hubble goes on the stream every week, so but you have to watch to the end if you want to see him. Anyway, I'm gonna keep working on this. Maybe sometime in the week, definitely next Saturday, and hopefully I'll have more of. I wanted to have like some like fractal Brownian noise terrain stuff with the height field rendering. So hopefully I'll have that working next week. For now we have infinite loops in the compute shader that lag the stream, memory bug stuff up in the top row, this kind of thing. So I guess that's the payoff for this stream. Anyway, I'm gonna sign off. Thanks everybody so much for tuning in, and I'll see you next week.